Good afternoon, students. Welcome. Now, today I am discuss the very important thing, the basics of IC engine. The IC engine and or the basic concepts of IC engine we will explain in the following manner. The first of all, we will discuss the introduction, then again classification, working of two-stroke, working of four-stroke, power cycles, volt timing diagram, IC engine combustion, working of simple carburetor, MPFI system, lubricant additives and their advantages. In internal combustion engine, in internal combustion engine, the combustion takes place within working fluid of the engine. Thus, fluid gets contaminated with the combustion products. The petrol engine is an example of internal combustion engine where the working fluid is a mixture of air and fuel. In an external combustion engine, the working fluid gets the energy using boilers by burning fuels or any other fuels. Thus, the working fluids does not come in contact with the combustion products. The steam engine is an example of external combustion engine where the working fluid is a steam. The internal combustion engine may be classified as follows: the spark ignition engine, compression ignition engine. The spark ignition engine, an engine in which the combustion process in each cycle is started by the use of an external spark. The compression ignition engine, CI engine, and an engine in which the combustion process starts when the air-fuel mixture self-ignites due to the high temperature in the combustion chamber caused by high compression. The spark ignition and the compression ignition engine operates on either a 4-stroke cycle or 2-stroke cycle. The 4-stroke cycle, it has the 4-piston stroke over 2 revolution for each cycle, and 2-stroke cycle, it has the 2-piston stroke over 1 revolution for each cycle. We will be dealing the spark ignition engine and compression ignition engine operating on a 4-stroke cycle. The internal combustion engine are classified as follows. The external combustion engine are classified into the 3 categories: steam engines, turbines and Stirling engine. And internal combustion engine are classified into also the 3 categories: Otto engine, diesel engine and Wankel engine. The application of IC engine in internal combustion engine is an engine in which the combustion of fuel oxidize. The mixture occur in a confined space, applied in automotive rail transportation, power generation, ships, aviations and garden appliances. Show the internal combustion engine and their relative components in this figure. The internal combustion engine, 2-stroke engine, 2-stroke cycle engine. The power and exhaust stroke. Power and exhaust stroke. In process A, the ignition will be start. In process B, the piston moves downward, compressing fuel air mixture in the crankcase. The process C, the exhaust port opens, and then intake and compression stroke. In intake and compression stroke, the first process is inlet port opens. The second process, the compressed fuel air mixture rushes into the cylinder, and in process C, the piston upward movement provides the further compression. The internal combustion engine, 2-stroke. Advantages: the lack of valves, which simplifies the construction, and the lower weight. Fire once every revolution, which gives the significant power boost. Can work in any orientation. Good power to weight ratio. And drawbacks: the lack of a dedicated lubrication system makes the engine to wear faster. Necessity of oil addition into the fuel. The low efficiency produce a lot of pollution. Internal combustion engine for the 4-stroke cycle. In intake stroke, the pistons start moving downwards. In process B, the intake valve opens. In process C, the air fuel mixture gets in. In compression stroke, The process A, the piston moves up, both the valve closed, air fuel mixture get compressed. In internal combustion engine for 4-stroke cycle, in process A, the air fuel mixture explodes, the driving the piston downwards, and in exhaust stroke, the piston moves up. In second process, the exhaust valves open. In third process, the exhaust leaves the cylinder. The internal combustion engine for 4-stroke cycle. Discuss the advantages and drawbacks. Advantages: dedicated lubrication system makes to engine more wear resistance, better efficiency than 2-stroke engine. No oil in the fuel, the less pollution. And drawbacks: the complicated construction should work in horizontal position due to lubrication. In internal combustion engine or diesel cycle engine, discuss the advantages: the self ignition, better efficiency, reliability, higher durability, supplied with rose fuels. Drawbacks: more expensive, more weight, louder, and lower revolution. Internal combustion engine for multi-cylinders, cylinder layouts. Now discuss the differences in between the 2-stroke cycle engine and 4-stroke cycle engine. In 2-stroke cycle engine, lighter weight, but in 4-stroke cycle engine, heavier weight, operates in many positions. But in case of 4-stroke cycle engine, operates in limited position. 2-stroke cycle engine, higher power to weight ratio, but 4-stroke cycle engine, lower power to weight ratio. In 2-stroke cycle engine, the engine oil usually mixed with the fuel, and in 4-stroke cycle engine, the engine oil in a reservoir. In 4-stroke cycle engine, in 2-stroke cycle engine, the louder operation, but in 4-stroke cycle engine, in quieter operation. In 2-stroke cycle engine, the higher engine speed, but in 4-stroke cycle engine, the slower engine speed. In 2-stroke cycle engine, the more vibration, but in case of 4-stroke cycle engine, the smoother operation. More vibration in 2-stroke cycle engine and smoother idling operation for 4-stroke cycle engine. Assumptions for the air standard cycles. A perfect gas is used as a working medium, the transfer of heat that does not affect the temperature of source and sink. The wall of piston and cylinders perfectly insulator. The cylinder head is perfect heat conductor or perfect insulator as requirement. The working fluid has a mixed mass. The working medium does not undergo any chemical changes throughout the cycle. The specific heat, Cp and Cv, does not vary with the temperatures. The power cycle. In this power cycle, first of all, we'll discuss the Otto cycles, the air standards Otto cycle. In an ideal cycle that approximates the spark ignition internal combustion engine, it assumes that the heat addition occur instantaneously while the piston is at TDC. With the help of this diagram, we can explain this thing. In Otto cycle, the process 1 to 2 is an isentropic compression process where V1 is greater than or equivalent to V2 temperature. In process 2 to 3 is a constant volume heat input process, while at TDC, the ignition of fuel. The process 3 to 4 is an isentropic expansion process. The power is delivered while the entropy is constant. The process 4 to 1 is a constant volume heat rejection process. In diesel cycle, show the PV diagram of diesel cycle and TS diagram of diesel cycle. In process 1 to 2 is an isentropic compression process. And process 2 to 3, the constant pressure heat addition process. Process 3 to 4 is an isentropic expansion process. And process 4 to 1 is constant volume heat rejection process. Now, Carnot cycle, it's very important cycle. Show the diagram, PV diagram and TS diagram of Carnot cycle. In process 1 to 2, the reversible isothermal during this air expand and heat addition at temperature T1. And process 2 to 3, the air expand from temperature T2 to T3. The process 3 to 4, the air compressed isothermally and heat is rejected during this process. The process 4 to 1, the air is compressed adiabatically from T4 to T1. The dual cycle. Show the diagram, PV diagram and TS diagram of dual cycle engine. The process 1 to 2, the isentropic compression, process 2 to 3, the constant pressure heat addition process, process 3 to 4, the constant volume heat addition process, and process 4 to 5 in an isentropic expansion process, and process 5 to 1 is a constant volume heat rejection process. Brayton cycle. Show the systematic diagram for the Brayton cycle. In this cycle, the process 1 to 2 is an isentropic compression, process 2 to 3 is a constant pressure heat addition process, process 3 to 4 isentropic expansion, process 4 to 1 the constant pressure heat rejection process. Wall timing diagram. Wall timing diagram. Show the different kind of stroke in this wall timing diagram or wall timing charts. Wall timing diagram for 4-stroke SI engine and CI engine. Wall timing diagram for 2-stroke cycle engine. Stage of combustion in SI engine. We'll explain further for the stage of combustion in SI engine. In process 1, the ignition lag. It is related with the growth and development of a left propagating flame. The flame propagation during this, the sudden pressure and temperature rise, the heat release, the rate is depends on the turbulence intensity and rejection rate of charge. After burning, this is instant at which the pressure is reached on the indicator diagram. The velocity of flame decreases, so combustion rate decreases, since the expansion strokes start before this stage. In cylinder measurement, this graph shows the fuel rejection flow rates, net heat release, the rate, and the cylinder pressure for a direct ignition compression ignition engine, CI engines. Combustion in CI engine. The ignition delay. The combustion process processed by the following stages. The ignition delay. The fuel is injected directly into the cylinder towards the end of the compression stroke. The liquid fuel atomizes into the small drops and penetrates into the combustion chamber. The fuel vaporizes and mixes with the high temperature, high pressure air. The premixed combustion phase. The combustion of the fuel which has mixed with the air to within the flammability limits. The air at a high temperature. During the ignition delay period occur rapidly in a few crank angles. Mixing control combustion phase. After premixed gas consumed, the burning rate is controlled by the rate at which the mixture become available for burning. The rate of burning is controlled in this phase primarily by the fuel air mixing process. Let combustion phase. Heat released may processed at a lower rate well into the expansion stroke. No additional fuel injected during this phase. The combustion of any unburned liquid fuel or chute is responsible for this. 4-stage of combustion in CI engines. Squeezing. It is the process of cleaning or sweeping out the exhaust gases from the combustion chamber of the cylinder. It is necessary that the cylinder should not have any burned gas because they mixed with the fresh incoming charge and reduce its strength. The power will be lost if the fresh charges is diluted by the exhaust gases. The squeezing is necessary only in 2-stroke engine, since the piston does not help for cleaning the burned gas from the cylinder. Types of squeezing. cross flow squeezing, full loop or back flow squeezing, uniform flow squeezing. Pre-ignition. In SI engine, the combustion during the normal working is initiated by the electric spark, and the spark is timed to occur at definite point just before the end of compression stroke. The ignition of the charge should not occur before the spark is introduced in the cylinder. If the ignition start due to any other reason, when the piston is still doing its compression stroke is called as pre-ignition. Pre-ignition occur due to the following reason: the high compression ratio, overheated spark plug points, overheated exhaust valve. It may occur due to the faulty timing of spark production. Effects of pre-ignition: reduce the useful work per cycle, increase the heat losses from engine, reduction in thermal efficiency, subjected the engine components to excessive pressure. Detonation. It is the indication of abnormal combustion is engine cylinder. In normal combustion of SI engine, the spark is produced just before the end of compression stroke. In abnormal combustion, after the combustion produced, there is rise of temperature and pressure due to the combustion of the ignited fuel, which leads to propagate the flame to remote part of the cylinder, and charge present in the remote part reach to critical temperature. Effect of detonation: noise, mechanical damage, increased heat transfer, pre-ignition, decrease in power output. Simple carburetor. A carburetor primary purpose is to produce a mixture of fuel and air to operate the engine. Gasoline engine cannot run on liquid gasoline. It must be vaporized and mixed with the air in the proper proportion of varying condition. Carburation. The carburetor must create an air-fuel mixture that is correct for the different circumstances such as cold or hot starting, idling, part throttle, acceleration, high speed operation. Carburetor works on the principle of air pressure differences. When discussing the pressure difference, we will talk about how does it work. The air enter the top of the carburetor and is mixed with the liquid fuel. How does it work? Explanation of how does it work. This increase in velocity reduces the pressure, causing the fuel to be drawn into the air stream. The particles of fuel air are vaporized by air rushing through the venturi. The air-fuel mixture is forced into the intake manifold by atmospheric pressure and burned in the combustion chamber of the engine. A venturi is a restriction in an air passage that increases the air speed or velocity. Direct fuel injection. Show the diagram of direct fuel injection. Throttle body fuel injection. The injectors are located in the throttle body. The throttle body is the intake cavity or intake manifold. The carburetor is removed from the intake manifold and simply replaced by a fuel injection system. Multi-port fuel injection. Thank you.